Okay, so this video is going to be about how to test polar equations for symmetry, which will lead you into how to graph these polar equations by plotting points. Okay, so the test for symmetry has three components. The first component is you're testing for symmetry with respect to the polar axis. The polar axis is just the x-axis. So that's this axis. What we want to do, and these tests for symmetry are there so that you don't have to plot as many points. If you know a graph is symmetrical with respect to the x-axis, any point plotted above the x-axis you can reflect below the x-axis. As you can see on this graph right here, do you see r theta is reflected over the x-axis to be r negative theta? And so you know if that point r theta is there, then you also know r negative theta is there, if the graph is symmetrical with respect to the polar axis. You determine this by using this test where you replace theta by negative theta in your equation and simplify. For example, if you have the equation r equals, oh boy, hold on. Okay, if we have the equation r equals 2 sine theta, and you're asked to test to see if that's symmetrical with respect to the x-axis, what you do is you plug a negative theta in for theta, r equals 2 sine negative theta, and then you simplify. And we know that since sine is an odd function, when you take the sine of a negative angle, that negative can be factored out. And when we simplify, we get r equals negative 2 sine theta. Is that the same thing as r equals positive 2 sine theta? No, it is not. So that means it is not necessarily symmetrical. Okay, necessarily is the key word. It still could be symmetrical, but you just can't bank on that. Now, with that same idea in place, let's do r equals 2 cosine theta. If we do r equals 2 cosine theta, we see r equals 2 cosine negative theta. Because cosine is an even function, we know that the cosine of negative theta is the same thing as the cosine of positive theta. So essentially, because cosine is an even function, that's the same thing as r equals 2 cosine positive theta. Now, if we look back, we see that our simplified function is identical to the initial function. So for this reason, we know that this is symmetrical. With respect to the x-axis. Okay, so now that we know that, let's move on to the next type of symmetry. That's symmetry with respect to the line theta equals pi over 2. That is the line, the y-axis. Okay, so when you're testing for symmetry with respect to the line theta equals pi over 2, you're going to replace theta by pi minus theta. So again, in our example problem, r equals 2 sine theta. We're going to replace theta with pi minus theta. So r equals 2 sine pi minus theta. And in doing that, we're going to have to use our addition and subtraction formulas from chapter 7. So we're going to say r equals 2, and that's going to be sine pi cosine theta minus cosine pi sine theta. And if we simplify that, we get 2. Sine of pi is the y value at pi, which is 0. So 0 times cosine theta minus cosine of pi. Cosine of pi is negative 1 times sine theta. So if we simplify that, we get r equals 2 times 0 minus negative sine theta, which is r equals 2 times sine theta, because the double negative. So do you see that 2 sine theta is the same thing that we started with. So because of this, this graph is symmetrical with respect to the y-axis. So that means anytime you plot a point in quadrant 1, you can reflect it into quadrant 2. So it really does help. Last element of the test is symmetry with respect to the pole, or symmetry with respect to the origin. When something is symmetrical with respect to the origin, that means you could pick the point up and rotate it 180 degrees and put it down, and it would land, or pick a graph up, rotate it 180 degrees, and it would land on itself. So to determine whether or not a graph is symmetrical with respect to the pole, this is the easiest one. Excuse me. And the one that you'll find is most often doesn't work, is where you replace r by negative r. So in this case, we're going to say if we're using r equals 2 sine theta, we're going to replace r by negative r. Negative r equals 2 sine theta. And if, to get r by itself, we'll divide both sides by -1, and we get r equals -2 sine theta. Do you see that that does not match? Since it does not match, we know it is not necessarily symmetrical with respect to the origin. Remember, that doesn't mean it's not. That just means that you can't bank on it. You can't just assume that. So in the next video, I'm going to actually show you how to use this test.